Hi students, here I am going to discuss one more concept from the stereochemistry, that is nothing but identification of the relation between given compounds. Okay, so you can see here nearly 10 pair of compounds are there. So let us give the relationship like identical or enantiomers or diastereomers. Okay, so the first compound here, first pair of compounds, in this case we can go through that the configuration. Okay, for suppose is the first priority, and here the second priority, this is the third priority, and this is the fourth priority. Okay, so a 1 2 3, this is the anti-clockwise direction, so S configuration, but here least priority group must be here is on the horizontal line, so generally we will take the reverse. Okay, so that is configuration R. So here in this case, why we should take the reverse when least priority group on the horizontal line, that I discussed in one video. That video link I will give in a description. Okay. Next, here in this case, first priority, here second priority, this is the third priority. 1 2 3, here anti-clockwise S configuration. Here in this case, hydrogen least priority group on the vertical line, so we can take that direct. For the clockwise direction R configuration, for anti-clockwise direction S configuration. So it's chiral carbon configuration or chiral carbon configuration S. So here in this case, these two carbons have opposite configuration from 1 to 1. So these two are the enantiomeric compounds. Okay, enantiomeric pair. Okay, the relation between these two compounds, enantiomers. Okay, and next here, see this one here in this case, again we can give the based on the RS configuration, we can answer this question. So here in this case, first oxygen attached group, so first priority. Next aldehyde CHO and CH2OH, here this one second priority, and this one third priority. Okay, so here in this case 1 2 3, this one anti-clockwise direction, so S configuration, that is the S glyceraldehyde. Now here let us check the configuration of this compound. Here first priority, in second priority, this one third priority, 1 2 3, that clockwise direction R configuration. So here least priority group on the horizontal line, so no need to take the reverse, so S configuration, here R configuration. Again here these two are the, you can say, mirror images and enantiomers. Okay, these are also enantiomers. Next, here coming to this one, here in this case, what is the relation between these two compounds? Here in this case, first let us check the configuration of each chiral carbon. Okay, so here first priority, here in this case methyl carbon, here it is a methyl, just it is a, but it is tertiary, so second priority, and this one third priority. So here 1 2 3 clockwise direction R configuration, because we least priority group on the vertical line. So next here, for this chiral carbon, this is the ethyl group, so CH2 CH3, and this is CH3, but this carbon is further attached to the fluorine, so high priority, this group getting a high priority, and ethyl second priority, methyl third priority. Okay, so 1 2 3, this one clockwise direction, so R configuration, but here least priority group on the horizontal line should take the reverse, so S configuration. Okay, so here for these two chiral carbons, so one RS configuration and one chiral carbon S configuration. Okay, and next here, what about the configuration of these compounds? First of all, let us write this compound in a Fisher projection formula. Okay, so here in this case, this is the actual compound. This one methyl downward, this is the front carbon actually. Okay, this is the front carbon, nothing but bottom carbon, so ethyl, and here hydrogen, and this is methyl. Okay, so next is a rare carbon, on the rare carbon fluorine right side, here hydrogen on the left side. Okay, so here in this case, this methyl downward direction, here this ethyl upward direction. So now here convert this one, you must bring that ether also in a downward direction. Okay, so it is a methyl, here in this case ethyl, and this one here methyl, and here hydrogen. Okay, so that means here by rotating 180 degrees about this CC, about this bond. Okay, so here in this case we can convert this one into directly 2D compound. That means here you can see like this. Here hydrogen and fluorine. This is a methyl. Okay, it is a rear carbon, it is a top carbon, it is a front carbon actually. Here this methyl, hydrogen and ethyl. Okay, it is a 2D form of that compound. Now here give the RS configuration, first priority here, next second priority, this one third priority, 1 2 3 configuration. So R, but you have to take the reverse, so S configuration. Okay, and next here about this carbon, the first priority here, second priority, this one third priority, 1 2 3 R configuration, but take the reverse configuration. So because here least priority group on the horizontal line, so yes one. So here in this case this compound has a RS configuration. Okay, at one chiral carbon R configuration, at other chiral carbon S configuration. But in this case, both chiral carbons have the same configuration, S configuration and S configuration. That means here these are not the mirror images; these are the just diastereomers. Okay, that means here the isomers which are not mirror images, maybe active or inactive, are the diastereomers. Okay, isomers which are mirror images are the enantiomers. So in enantiomers, all chiral carbons configuration is inverted actually. So here in this case, if you take the enantiomers like this here, one is a RS, it's enantiomer S R configuration, or SS configuration, it's enantiomer RR configuration. Okay, that's it. So here C are the diastereomers. And next here in this case, fourth pair of compounds here, these two are the actually mirror images, because in this case this methyl upward direction, this methyl downward direction, this methyl downward direction, this methyl downward direction. So it is a 1,2 trans compound, it is a 1,2 trans compound. Okay, so here these two are the mirror images exactly. It is a downward, it is a upward, it is upward, it is a downward. Okay, that means here if you put mirror under this molecule, we can see this image in a mirror image actually. Okay, so these two are also again enantiomers. Okay, that's it. So next coming to the compound E, here also same, we can proceed here first priority, and here second priority, this is third priority, 1 2 3 configuration. So actually here anti-clockwise direction, so yes, but we have to take the reverse R configuration. Next here first priority, second priority, third priority, here 1 2 3 clockwise direction, so R configuration, because the least priority group on the vertical line, so R configuration, these are the identical. Okay, next here coming to this one, it is a somewhat a complex example. So here in this case, this ACO actually in these type of compounds, okay, this type of compounds here, these bonds are the endo bonds. Okay, and this one is the exo actually. So here in this case, these two are not mirror images, because this bond in upward direction, this bond is in downward direction. Okay, so of course these two are the diastereomers, because these are not the mirror images. Actually here this is the endo bond, this is the endo isomer actually. Endo isomer, this is the this is the exo isomer, this is the endo isomer. Okay, so here actually what is the mirror image of this compound? Okay, so here in this case for this compound we can write the mirror image like this. For suppose you can write like this, methyl here, methyl here, OAC. These two are the mirror images. So these two are the enantiomers. Okay, for suppose for this compound enantiomer, that means mirror image is like this, methyl here, methyl here, OAC. These two are the mirror images each other. Okay, these two are the mirror images each other, because this one is the endo, this one is also endo, but mirror images each other. Okay, this one is the exo, this one is also exo, mirror images each other. Okay, that's it. But here these two are the diastereomers, one is the exoisomer, one is the endoisomer. Exoisomer, endoisomers are the diastereomers. Okay, Next here, coming to this one, these two are the actually enantiomers. Okay, if you put mirror like this, okay, if you put mirror like this, here we can see this structure like this. Here in this case, methyl methyl, here double bond O, because only one carbon here. Okay, now here there is a double bond, here methyl, because these two are the mirror images each other. Nothing but this is equal to this compound. These two compounds are same actually. Okay, so here these two are the mirror images each other and enantiomers. Okay, that means here this is a mirror between these two molecules, so you can see this structure. So these two are the mirror images, so enantiomers. That's it. Next here, coming to this one, it is somewhat a different example. So in this case, you can see it is actually a source projection, it is a Newman projection. Okay, now here this one, uh, we have to write in a Sawhorse projection formula. Okay, for this compound, what is the Sawhorse projection formula? Here we can see like this. Okay, because it is a front carbon. Okay, it is a front carbon. So it is a front carbon means here this is a vinyl group, and here chlorine, and here hydrogen. The circle is a rare carbon, so on the circle downward vinyl, here right side chlorine, here left side hydrogen. That's it. Okay, here in this case, actually there is a center of symmetry. There is a center of symmetry. So this compound is a inactive compound. Of course it is a meso compound. Now we are coming to this one. Here in this case, it is a vinyl group, it is a vinyl group. Okay, so I am writing again here like this. Here chlorine, here hydrogen, here chlorine, and here hydrogen. This is the vinyl group and this is the vinyl group. Of course these two vinyls are opposite, but in this case carbon chlorine, here carbon chlorine, these two bonds eclipsed bonds. Here carbon hydrogen, here carbon hydrogen, these two bonds are eclipsed, but it is a staggered conformation actually. Okay, it is a staggered conformation. Here CH bond, here upward direction. Of course these two are opposite, these two are opposite, these two are opposite exactly. Okay, so it is you know that it is a staggered conformation, or of course here completely anti-conformation, nothing but staggered conformation. Okay, here in this case, this is a partially eclipsed conformation. Okay, because vinyl groups are opposite, but here carbon chlorine, carbon chlorine, carbon hydrogen bonds are eclipsed. It is a partial eclipsed bond. So in this case, this is optically active, this is optically inactive. So here in this case, it is a meso compound, and it is not a meso compound. So actually we can say directly the relation between these two compounds is the diastereomers, because optically inactive compound and optically active compound are not the mirror images. So these two are again diastereomers. Okay, and next here, coming to this one, very interesting example this is. Here in this case, what is the relation between these two actually? Okay, of course it seems to be identical, but these two are the enantiomers. Why these are the enantiomers? Here, just let us think, this is the open chain compound. Here for suppose this is the one group, okay, this is a second group. Okay, that means just it's not a priority, just I am giving the numbering. So it is a below the plane third group, here above the plane fourth group. Okay, so first group, second group, third group, fourth group. Just I am giving numbering, it's not a priority. Okay, be careful. So here in this case, again here first group, here second group. Now here in this case, this oxygen group below the plane. Here in this case, this oxygen group above the plane. That means here for this one 3. Okay, so here in this case this is a 3 and this is the 4 actually, because here this oxygen group below the plane, here in this case oxygen group above the plane, here this CH2 group above the plane, this CH2 below the plane. That means here these two are the mirror images exactly, because these two are on the plane. Here in this case above the plane group is fourth one, here below the plane third one, here in this case reverse. So these two are the mirror images each other, nothing but enantiomers. Very interesting example this one. Just here consider these two bonds on the plane. Here one bond below the plane, one bond above the plane. Here the oxygen below the plane, here but here oxygen above the plane. Okay, there is a configuration is changed. These are the mirror images each other. Okay, that's it. So these two are the enantiomers. And now finally, what is the relation between these two? Here in this case, very interesting this one. You can see in this case, this is the axial, this is the equatorial. This is equatorial, this is the axial. Now these two are the mirror images because your configuration is changed. Here in this case, I am writing this structure, okay, in a cyclic structure. That means a 5-member ring I am writing. Okay, so here in this case, ethyl group I am writing below the plane. This ethyl group I am writing below the plane. Okay, next here this methyl upward direction, there is the equatorial above the plane. This ethyl upward direction towards upward, so here in this case ethyl. Now we are coming to this one. This ethyl upward direction, so ethyl above the plane. Here upward direction methyl above the plane. Now ethyl is a downward direction, so ethyl below the plane. Now in this case, these two are the mirror images actually. Okay, these two are the mirror images. Here in this case, actually here this carbon is not a chiral carbon. Okay, so it is a chiral carbon, it is a chiral carbon. Here configuration is changed. It is a chiral carbon, it is a chiral carbon. Configuration is changed. Okay, so here in this case, these two are the mirror images each other enantiomers. Okay, so for suppose if you consider the configuration, here in this case ethyl group, here secondary CH2, here tertiary first priority, here second priority, this one third priority. Okay, so here 1 2 3, actually yes, R configuration clockwise direction, but here a hydrogen above the plane, so you should take the reverse configuration. Yes, for this one first priority, second priority, third priority. 1 2 3 S configuration, because least priority group below the plane. So here in this case S configuration, here S configuration. Finally, now this one R configuration, and this one is also R configuration. That means here mirror images. What about this one? Okay, it's not a chiral carbon in this case especially. Why it is not a chiral carbon in this case? Because here this one and structurally same. CH ethyl, CH ethyl structurally same and also configurationally same. Of course, if structurally same and configurationally different, for suppose it is a R configuration, it is a S configuration, then it is also chiral carbon. That is nothing but pseudo chiral carbon. That video also we can see. I will share the link for in a description. Okay, what is about the pseudo chiral carbon. Okay, so in this case S configuration, we cannot give the configuration for this one. It's not a chiral carbon because here configurationally same groups are attached. They're also same, so that's why you can ignore the stereochemistry of this one. But here about these two chiral carbons, these two are the chiral carbons are inverted configuration, so these two are the enantiomers. Very interesting example this one. Okay, thank you for watching. So in this series I will discuss some more problems which are very useful for the JEEadvanced exam. Okay, so from all chapters I want to discuss some problems, okay, with your support. Please like, share and subscribe my channel.